Here's your lesson for section 7.2, Ratios and Similar Polygons. Missy McCarthy, Okemos High School Math Instructor. In this video, you'll learn to identify what we call similar polygons and apply properties of similar polygons to solve some problems. Alright, so before we can apply or solve problems, we need to know what similar polygons are. And here's our definition right here. It says that two polygons are similar polygons if and only if, so you should remember that it's a biconditional statement. So, and all of our definitions are biconditional statements. Two polygons are similar polygons if and only if their corresponding angles and are congruent and their corresponding sides are proportional. So if we look at this figure here, figure ABCD and figure EFGH, we can see that the two right angles are congruent. A and D are congruent to E and H, and then the other two angles are congruent. B is congruent to F, and C is congruent to G. So the corresponding angles are congruent. That's one condition for similar figures. The other thing that has to be true about similar figures is that their sides have to be proportional. So that means if I do ratios of corresponding sides, they should all be equal. So 5 is to 10, just as 4 is to 8, just as 6 is to 12, just as 5.4 is to 10.8. All of those ratios equal 1/2, and that means that their sides are proportional. So then these two figures would be similar. So we would say figure ABCD is similar to figure EFGH. A similarity ratio is the ratio of the lengths of the corresponding sides of the two similar polygons. So in the previous example, the similarity ratio was 1 to 2, or 1/2. Similarity ratio here, if we take one corresponding side, this side here, and we do the ratio A to B is as D to E, that would be corresponding to each other. So if we do 3/6, our similarity ratio is 1/2. Now that's if we're going from this figure to this figure. Now it says the similarity ratio, if we were going from this figure to this figure, you would have to go in the other direction. You would have to do 6 to 3, which would be 2/1. So pay attention where you're going from and where you're going to when you're finding your similarity ratios. Alright, so we're going to determine if these two polygons are similar. Again, in order to be similar, by definition, they have to have all corresponding angles congruent and corresponding sides proportional. If they are similar, we're going to write the similarity ratio and a similarity statement. So I'm going to try the angles first. We know that angle M is congruent to angle N. We know that angle L is congruent to angle P. And by the third angles theorem, that means that angle J is congruent to angle S. So all of the corresponding angles are congruent. So now let's do the sides. So LM, because we're going from L to M, that means we have to go from P to N, because L corresponds with P and M corresponds with N. So my first similarity ratio would be LM to PN. What do I get for that? I get 60/24, which 6 goes into both of those. That would be 10/4. Actually, 12 goes into both of those. It would be 5/2. Alright, for my next ratio, I'm hoping I'm going to get 5/2. So this time I'm going to do JM, and I'm going to have to do SN. So JM to SN. JM is 45, SN is 18, 9 goes into both of those, 9 goes into 45 5 times, 9 goes into 18 2 times. Alright, so I got one more to try. My last two corresponding sides, which would be JL and SP, JL to SP. JL is 75, SP is 30. I know that 5 goes into both of them, but I'm thinking something bigger. 15 goes into both of them. 15 goes into 75 5 times. 15 goes into 32 times. And so, yes, our similarity ratio is 5/2. Similarity ratio is 5:2. And our similarity statement, make sure that your letters are in the right order. So if I go from M to L and then to J, I can say triangle MLJ is similar to triangle NPS. NPS. Okay, so show that they were similar. I show what my similarity ratio is, and then I wrote my similarity statement. All right, so we got to determine whether or not these polygons are similar and do the same thing. If they are, write the ratio and the statement. So for the angles, I don't really know much about these angles. I don't know if they're right angles. I don't know anything. So I'm going to say, because I don't know if the angles are congruent, I do not have enough information to say whether or not they are similar. So I'm going to say not necessarily similar. They could be, but I don't have enough information to determine. Not necessarily similar. All right, for these, let's see if I have enough information. Well, yeah, both of these are 10, so these sides are congruent. So I know that this has to be an isosceles triangle. And I also know the angles have to add up to 180. So I'm going to do the 180 minus 36. And that gives me 144. And then I'm going to divide that by 2, which means both of these angles are 72 degrees. All right, so now I'm looking at this one, and then this has to be 62 degrees. And then 62 times 2 is, oops, yeah, I did that right. 62 times 2, then 180 minus 124. So this would have to be 56 degrees right here. Let me make sure I did that right. 72 plus 72 plus 36 equals 180. 62 plus 62 plus 56 equals 180. And because the angles don't match, these are not necessarily similar either. Now, for these, if we had known that these were right angles, we could have gone ahead and did it. If we would have been given this information, and then we would have done 6 is to 4, 9 is to 6, and we would have known it was a rectangle, so this would have been 6, and that would have been 9, this would have been 4, and that would have been 6, and we would have said yes. But because they didn't tell us that those are right angles, nor did they tell us that that figure was a rectangle, we can't do anything more with it. All right, so we're going to use similar figures now to apply, or we're going to apply similar figures, maybe I should say, to find the length of the model. All right, so we're assuming that all the angles in the cars match and that they are indeed similar figures. And we're going to set up a similarity ratio then, or proportion from our similarity ratios in order to find the missing length. So 1.8 meters is to 6.3 centimeters. 1.8 meters is to 6.3 centimeters, just as 5 meters is to x centimeters, just as 5 meters is to x centimeters. Then we're going to solve our ratio or our proportion just like we did before in the previous lesson, and we're going to cross multiply. And when we cross multiply, we're going to get 1.8x equals, let's do 5 times 6.3, and that would be 31.5, and then divide both sides by 1.8, and we get x is equal to 17.5, and this should be in centimeters, because our meters, centimeters, meters, centimeters, the meters will end up canceling out, and we would be left with centimeters. Now, if you wanted to do this by changing the centimeters to meters first or vice versa, you could do that as well. But if you have meters to centimeters, the units should work out for you. All right, and for this last one, we're going to find the value of x. If we know that triangle MNP is similar to triangle XYZ, so we know M goes with X, N goes with Y, and P goes with Z, so that gives us our corresponding sides and allows us to find the value of x. So PM is going to correspond with ZX. ZX. So PM, which is x plus 5, goes with ZX, which is 30. And then PN is going to go with ZY. ZY. So that's equal to PN to ZY. And now, to solve our proportion again, we're going to cross multiply there and there. We end up with, oops, got to grab my pen again. We end up with 75 times x plus 5 is equal to 30 times 4x minus 10. That gives us 75x plus, not quite sure what that is. It's like 475 or something. 75, oh, it's not that big. Times 5 equals 375. There we go. Equals 120x minus 300. Subtract the 75, so 120 minus 75, that gives me 45x over here. Add the 300, that gives me 675. And then if I do 675 divided by 45, I end up with x is equal to 15. So if x is 15, those two triangles would be similar.